Welcome to Engineered for Impact, a podcast helping engineers learn and think more about how they can have a positive social impact with their careers. In this episode, I talk to Jeffray Behr, a food process engineer at New School Foods and a passionate advocate for the alternate proteins industry. We discuss his journey from being an undergraduate mechanical engineer to working in the alternate protein industry, and his advice for others who are interested in following a similar path. Specifically, we cover his advice for entering the alternate protein industry from any part of your career, but with a particular focus on university students and early career engineers. We also cover what his work as a process engineer at New School Foods looks like, and the opportunities available for engineers across the alternate protein industry. As Jeffray points out, there is a huge need for talent in all aspects of the field, from product development to scaling up the production process across a broad range of engineering disciplines. So if you're considering a career in the alternate protein space, there's definitely no shortage of ways for you to make a difference. You'll find show notes with links to learn more and ways to support the podcast at engineeredforimpact.show/Jeffray. That's Jeffray. If you enjoyed this episode, be sure to subscribe, leave us a review or comment, and share it with your friends and colleagues. So, without further ado, here's Jeffray.
So my name is Jeffray Behr. I'm a process engineer for New School Foods. So New School Foods is a plant-based fish startup based out of Toronto, Canada. And we're a very small team working out of Toronto Metropolitan University. So we're very much in the early stages of developing our plant-based salmon product. And my role as the process engineer is to take what we're doing in the lab scale and translate it to build out our first pilot production facility, which is already in the works, and I'm overseeing that project.
Fantastic. So I'm really excited to learn a bit more about what that work looks like at New School Foods. But first, I'd like to discuss the path that you've taken to get where you are today, because it's really fascinating to me. You seem to have a real drive and clear objective in how you've gone about transitioning from being an undergrad mechanical engineer to now working in a startup in the alternate protein space. So a few things that you've done along the way is you run a podcast on careers in the alternate protein or cultivated meat space. You created and maintain a careers guide, not just for engineers, but for anybody who's interested in working in alternate proteins. You volunteered your time to lead a research project at the Stanford Alt Protein Project, and you've worked on a number of other at a number of other alternate protein companies. So it's fair to say you're pretty all in on alternate proteins, I think. So I'm curious where that passion and where that interest came from.
Yeah, it's funny you mentioned it seemed like I'm very clear-minded. Well, I don't really feel like that was the case at all, ever. Even still to this day. For me, I'd say it all sort of goes back to about maybe 5 years ago when I was still in my undergrad. So I studied mechanical engineering at the University of Waterloo in Canada. And I think about midway through the that program, I discovered effective altruism. And effective altruism is sort of a philosophy and movement about trying to maximize the amount of good that you're able to do in the world. And that really resonated with me, and I really took it to heart and really wanted to commit myself to it and try to find a career that I felt would be as impactful as possible. So I did some research into what sort of other mechanical engineers could do as a really impactful role. And through some of my research into effective altruism and impactful engineering roles, I discovered a little bit about alternative proteins and the Good Food Institute. This is really interesting sort of cause area I never really gave too much thought about before, was helping animals, but I didn't really see much of a connection between the work that I'm doing as a mechanical engineer and like my skill sets and background into that. And I just kind of more or less put it off to the side as, it's kind of interesting, but maybe I'll just sort of like, I'll donate to that cause area and maybe that's how I can contribute. Because I thought it was something that was still really, really important. And then in terms of like mechanical engineering research that I'd done, the conclusion that I sort of came to was trying to really find jobs in the renewable energy sector, primarily for renewable energy in developing countries. I thought was something that was most impactful, because you can make much greater impact in developing countries as opposed to developed countries. And so after I had that sort of realization and discovered more effective altruism, I did my next co-op or internship. So the program that I studied at University of Waterloo is a really good program because it has built-in co-op program. And so during your schooling, the program's extended. Instead of being 4 years, it's 5 years. But because of that, they add in 6 different co-op terms. So I had the opportunity to try out working in 6 different companies and different types of roles, and really sort of see what I like and don't like. And that was really valuable, because when I started my undergrad, I had no clue what I wanted to do. So those internships and co-op experiences were extremely valuable.
What do you think were some of the biggest things that you learned from that? Like, what did you really find that you really liked, or perhaps really didn't like doing as a result of those co-ops?
I guess one of the takeaways was the team that you work with really sort of makes or breaks your experience. And it's not something that you really would think too much about. And it's hard to judge when you're going to be accepting a role. And it kind of gave me a sense of what types of jobs are out there, and the different, like I worked at large companies and smaller companies. I worked for the government for one thing. So I got to touch on a variety of different areas and industries as well. I did construction and agriculture and renewable energy and supply chain management and a bunch of stuff. So one of the things I also really enjoyed about that was going on site and getting more hands-on work, and sort of doing that was things that I realized, okay, this is what I like and this is what I don't like to do. Like I really liked working in spreadsheets and doing more analysis. I didn't really like writing reports or stuff like that. So, and sort of little things like that, and really just gaining experience working in the industry and like what it's like to just be in an office setting, and like just the little how to operate socially in an office environment, I guess. In the workplace, it's not something that you can really prepare for in school. So that was a really important thing.
Yeah, that makes a lot of sense. So you discover effective altruism, and you realize that impact and having sort of a positive social impact on the world is something you really want to do with your career. You've explored some of the ways you could do that as a mechanical engineer, and sort of settled on perhaps renewable energies in third world countries as a potential option. Where did alternate proteins come into the mix then?
Yeah. So just to sort of wrap up there on the renewable energy side of things, my second last co-op was for WSP, which is a engineering consulting firm, where I worked in their sustainability and energy department, where I helped buildings achieved their LEED certification. So it's an environmental standard where they try to reduce their energy and water consumption. And so that was my first foray into renewable energy and sort of the energy sector, and that was informative. And then my last co-op was actually working for a renewable energy nonprofit in India, actually. So that was an extremely informative experience, getting to actually go to a developing country, live there, live with the locals, because it was an extremely remote community there. And I helped with their, they had a biomass gasification plant. So essentially, they would hire local women to collect pine needles that would otherwise potentially cause forest fires. And then they'd use that to um, essentially burn in a giant reactor. And the gas from the combustion of that would power a generator, which would then create electricity for the local area. And then the byproduct, which was this ash, they would then convert into these charcoal briquettes, which they would use as an alternative cooking fuel source. So I helped there to optimize or make their plant more efficient and help scale up and expand their operations. And I really enjoyed that work. That was great. And after I returned from that co-op term, that co-op term was September to December of 2019. And so that was leading up to my final semester in my undergrad, which was the sort of winter 2020 semester. And my final year, I was okay, I should really start looking into getting a full-time job. And I was trying to connect with some people that had met at the conference the previous year in the renewable energy sector, and was having a few like virtual conversations with them because they were all over the world. Wasn't really having too much success. And then eventually decided, or I guess at the same time, I was doing this capstone project. So almost all engineering programs you do is sort of a capstone project in your final year. And the capstone project that I did was sort of trying to find an alternative to extrusion. So the idea of this project actually came from the Good Food Institute. So when I was choosing my project for this, I had reached out to the Good Food Institute, not really hoping that anything would come of it. Just saying, hey, because I knew someone there, and this is from back when I had done that sort of initial research when I was looking into alternative proteins way back a few years ago. And so I reached out to them and said, hey, I'm doing this capstone project. I have no idea what I want to do it on. Is there anything that you think like a group of mechanical engineering students could work on? And they said to me, oh yeah, for sure. Extrusion is extremely inefficient process. And for context, so extrusion is a method. Usually it's high moisture twin screw extrusion. So where you have two sort of interchanging screws that is under usually high moisture and pressure. And that's what's used to create textured vegetable protein, also known as TVP. And TVP is an extremely common ingredient or a component to almost all plant-based meat products. Like Beyond and Impossible both have them, and any other like nugget or burger, whatever it has. And it's really what gives it the sort of the texture, hence the name textured vegetable protein. Anyway, so it's a very it's a very inefficient process. It scales, but it's limited. It's very energy intensive, and frankly, after speaking with an expert on extrusion, he said to us like, honestly, it's a bit of a black box. Like we don't really fully understand what goes on inside there, and just there's so much uncertainty around it that there is control, but they don't have full control, I'd say. So the idea was to try to come up with a better form or alternative to extrusion. And so this is what a group of myself and 3 other mechanical engineering students in my program decided to work on for our capstone project. And that that experience while we were working on it, I had a revelation moment, and this is around March of 2020, when I was struggling to find a job in the renewable energy sector. And that's also when the pandemic just started. I had this realization, like, wait a second, I'm doing this project in sort of alternative proteins. You know, why can't I potentially get a job in this sector? Because clearly mechanical engineers are needed to design the equipment that's used to make textured vegetable protein and other plant-based meat products. I'm like, okay, well, maybe I should do a slight pivot, or at least try, because I wasn't having much success in this round, and or going down the route of renewable energies. Maybe I should just try going for alternative proteins. And so I reached out back to the Good Food Institute, my contact there, and simply sent them my resume, asking, like, do you even think I'm qualified enough? Is this like am I way off my rocker here? Is this crazy? Essentially, and like, is it even worth it for me to try to get into this industry? And they got back to me saying, "Oh yeah, no, your resume is great, especially for someone who's just out of university." And we shared it with a few people within our network, and one of them, Christy Legali, the CEO of Rebellious Foods, would love to meet with you. I'm like, oh wow, okay, great. What's Rebellious Foods? Quickly Googled it. Oh, okay. It's a plant-based chicken nugget company in Seattle. That sounds really interesting. Sure, okay. So I met with her, and we had a great call, and one thing led to another, and she hired me shortly afterwards. So that was sort of how I made this transition from university and going pretty much gung ho for renewable energy to pivoting 180 and doing alternative proteins, and here I am today. So it was definitely quite a pivot. And had you told me, even at the start of 2020, that I would be doing this, even like if in a few months and still doing it years later, I wouldn't have believed you.
That's awesome. I mean, it's interesting how such a small thing as doing your capstone research project in that field can sort of just snowball into a job offer. And I think what's striking to
Yeah.
me as well is just the opportunities you had through the co-ops to gain some actual industry experience. I know for me, throughout my university education, we didn't have an equivalent thing. I did an internship at a building services engineering firm, and found that really interesting. Gave me some interesting insight to what I did and didn't like about working in that industry. But other than that, I was didn't have much to go on. So it's really awesome that you're able to use those co-ops as a way to sort of explore some of your areas of interest, and then ultimately, I guess, build your resume up so that when Rebellious took a look at it, they were like, "Yeah, we'd love to have a chat with him."
Yeah. Yeah. I think looking back on it now, I don't think anything I really learned from any of those co-ops at least tangibly helped me, at least in this industry now. Like, I completely pivoted. It's more sort of the soft skills that I gained, especially just learning to be really adaptable and flexible, and developing more people skills. I think that's really what is the benefit of getting that work experience, not necessarily the tangible skills that you'd gain from it.
Yeah, yeah, I think that's right. I think yeah, those meta skills are just extremely valuable and are a great tool to have in your toolbox when it actually comes to being out there in industry, no matter where you go. So I guess to me, it just seems like it's the kind of industry that it's such early days for the industry that they're kind of just looking at, or at least in the past, they've just been grabbing things off the shelf that kind of worked well enough and allowed them to get the job done because it's still sort of in the proof of concept stage. But
Mm-hmm.
it's not perfect. It's not necessarily super fit for purpose equipment or machinery, and there's just a huge amount of scope for new machines to be created, and that's where engineers come in, as mechanical engineering in particular with the machining, but then the whole array of engineering disciplines across mechanical, chemical, civil, electrical, um, and I'm sure a handful more, just coming together to actually design machines that are tailor made for the alternate protein space. Is that the impression that you've got over your years now working in the space?
Yeah, definitely. That's the case. Like, there's the processes that they're using for making plant-based meats aren't exactly the same, and it took the meat industry many years to get up to the level of efficiency that it is now. So you can't just expect the plant-based meat industry to get up to that level just so quickly. Like, it's going to take a lot of time and R&D to get to that stage.
Do you have a feeling for how much room there is still to improve things?
Honestly, I think we're barely scratching the surface. And I say that mainly because there's relatively few people working in sort of the innovative and cutting edge development of these new types of technologies. And just with more people working on it and more innovation and more time, I think we can really massively transform the production of plant-based meat products to realize much greater efficiencies.
So you've done your own part for helping draw more attention and bring more people in to help solve those inefficiencies and bring about that innovation. And you've done this by two methods: your careers guide for ending factory farming and your podcast as well. So, can you tell me a little bit about, starting with the careers guide? Where did that start from? What was sort of what precipitated your decision to start a careers guide for ending factory farming?
Yeah. So I think it was in April 2021, or sorry, no, February 2021. I signed up to be a part of the SHIPS program. I think it's like student led high impact projects. I think it was the acronym. It was led by, I think, the Effective Altruism Group in Brown University. And because I wanted to do something a little more impactful in my spare time, essentially. Um, so I when I joined that program, they essentially said, like, you need to come up with an idea to work on over the next few months. And so I spent some time thinking about it, like, what do I want to do? I had a short list of ideas that I thought were had some merit. One of them was essentially trying to find like the what I ended up doing was the career guide for ending factory farming, which is essentially a guide to help people who want to get into the industry but don't really see how they can use their skills or background to help. And funnily enough, and somewhat ironically, the other idea that I had came up with was similar, and is exactly what you're doing, which was trying to find a way that engineers could have much more impactful roles. So had we connected maybe back then, I might have gone down that route instead. And both of those ideas stemmed really from my personal experience of studying mechanical engineering and not really realizing that I could contribute more than just through just pursuing renewable energy. I didn't realize that there is so many other ways that I could use engineering to have more of a high impact role. And then in terms of the plant-based meat side, like I just kind of initially kind of never really thought about it. I never made the connection of how mechanical engineers are needed to help the industry, and just didn't pursue it any further. And so I think there's a lot of people out there who are probably similar in the sense that they want to contribute, but don't really see a way that they can, or don't really feel confident enough, or don't know how to even just get started to learn more. And so that was really the purpose of the guide, is to sort of educate people on, first off, the variety of different roles that are needed in this sector, as well as to provide just sort of general background and advice on how to best get into the industry. And so that was what I worked on for I think 3 or 4 months, as a part of this SHIPS program, and a few people were able to help me develop this guide, because it was a lot of work. It ended up being more than I thought it would be. And so I did that in 2021, and then after I finished the guide, I think in around May or so, I just kind of left it. Okay, that's good. Yeah, and then a few months later, I had this sort of idea that popped in, like, oh, I really want to take that guide to the next level, but wasn't really sure how to go about doing it. And then one day I was just walking, and idea popped in my head, like, oh, well, why don't I sort of make it into a podcast somehow? And with the idea of the podcast being that I would highlight the variety of different roles that are available in this industry. The idea is that because I've highlighted all the different career opportunities that are in the industry, and so I want to speak with a person from each of those different areas, and so someone who's listening can see actual, like, tangible experiences of someone doing a role in, say, the policy side of things in the alternative protein industry. So that was really what transitioned from the career guide to this podcast. And going back to the career guide, I've now realized it's a little bit outdated, and so I'm currently in the process of re-updating it.
Fantastic. And what are some of the topics you have in there for engineers in your careers guide? What sort of engineering disciplines? What are the kind of works that people in those disciplines can do?
Right. So in terms of engineering, I think there's a whole subsection dedicated just to engineering. One of the most common ones, or highly needed ones, is bioengineering, especially for developing cultivated meat or cultured meat products, developing better scaffolds, developing more growth media, and from more of a chemical engineering side of things, there's definitely the bioreactor design. So bioreactors are what's used to make cultivated meat, as well as any sort of fermentation-derived products. Also use bioreactors. Mechanical engineers obviously needed for developing new types of equipment and technologies. So another alternative to extrusion is shear cell technology. There's a company in the Netherlands, I think, called Rival Foods, and they're a group of mechanical engineers that are trying to develop a way of making whole muscle plant proteins using this shear cell technology as opposed to extrusion. And then more generally speaking, there's just a lot of engineers needed to sort of build out and scale up production facilities for plant-based meat projects. In my current job, I work with a lot of mechanical, electrical, and structural engineers, and they're the ones that are physically designing the the actual engineering drawings for what our pilot production plant is going to look like. And so those roles there are very needed. And on top of that, I think long term, similar to the meat industry, is extremely automated. I think once we get up to that stage, the plant-based meat industry will also aim to try to be very automated as well. And so that's maybe where more like automation and more like computer engineering can play a role as well.
Awesome. So for somebody who's in university, maybe they're 1 or 2 years from graduating, and one of those ideas really caught their interest, perhaps working in biomedical, bioengineering, chemical, civil, any of the disciplines really. How would you recommend they start thinking about approaching getting into a career in alternate protein? How do they set themselves up for success in that space?
That's an excellent question. First off, I think something that you really need to do is really gain a good understanding of the industry, and the different types of technology that's being used. So there's, as GFI likes to say, the Good Food Institute, there's 3 main pillars. There's plant-based products, there's cultivated products, and then there's fermentation-derived products. So really understanding those 3 different sectors, because they all have their different areas where they need further research and development, and engineers can contribute differently to each of those areas. So I think that's why, first off, it's really important that you understand where it is, and then maybe where you can best contribute to one or multiple of those 3 pillars. Secondly, I would probably say gain experience in the food industry, or take food-related courses, or just I guess get more involved in food, because that's really what it boils down to. Just the alternative protein products are food. So understanding how food manufacturing and processing works is also really important. When I joined Rebellious, I had 0 food industry experience, and I learned a lot from just my time working there, and food safety being such a critical component, and just understanding the fundamentals of that and what can and can't be done in a food production facility is really important. So that would be my sort of second piece of advice, and because that's not something that people would necessarily think of as like, oh, I'm just going to be an engineer doing this, engineering work. No, you really need to understanding how food is made on any level, really. And then lastly, I'd say try to build your network in this industry, because the alternative protein industry is very unique in the sense that it's a very tight-knit and extremely supportive community. Everyone is really mission-driven, and they're all going towards the same goal. And so everyone's willing to help each other out. It's not as very competitive as some other industries. And so one way that sort of can assist with the sort of building your network and being a part of the community is through GFI's Alt Protein Project program. So recently they I think this started back in 2020 or 2021, I think was the initial program. So they had, essentially it's like a club at your university that is dedicated towards developing and promoting and educating people on alternative proteins. And I was actually a part of the Stanford one when they helped were initially starting it up. Even though I never went to Stanford. It was all virtual at the time because that was during the pandemic, and I was working in the industry, and they wanted someone who would, was a little more knowledgeable to help them take it to the next level and get them up and running. So it was extremely great way for students, university students, to get involved and learn more about it. And it's a great thing to have on your resume. And I know since then, the Alternative Protein Projects program has expanded to over 20, or they added on 20 chapters just last year. And one of them was the Waterloo Alt Protein Project, which I helped get that one started up as well. And I just read recently that they are now accepting applications for the next round of alt protein projects. So if you're at your university and your university currently doesn't have an alt protein project, you can apply. Maybe you can put a link to the show in the show notes to the application process, and potentially that's a way that you can sort of build up more of a alt protein presence at your university. I would definitely recommend that, because not only do you get more involved in alternative proteins, you get connections with the Good Food Institute, as well as just the soft skills that you'd gain from running a club like that is extremely beneficial.
For sure. Yeah, we'll definitely put a link to that, as well as the Good Food Institute, and some of your top recommendations for some reading on there for engineers into the show notes. What were some of the projects that you sort of helped oversee and set up at Stanford as part of the alt protein project?
Yeah, so I was the research lead there. So I really only led that one particular project. And what my approach, at least, to the research side of things, is very, very open ended, because they're really in the early nascent stages of developing that program. So I kind of interpret, like, well, we want to get more research done at the university into alternative proteins. How do I go about doing that? Let me think about this. And I thought, well, what if we sort of reached out to professors, really just cold emailing, and but targeted cold emailing, in the sense that we weren't just spamming all of the professors. We were looking into ones that we felt had particular expertise. So GFI has what they call, like, the solution database of all the challenges that need to be solved in order for the industry to really grow and take it to the next level. And so I read through all of those solutions, and I kind of honed it down to, like, a few that I thought were generally relevant to the area that Stanford currently does a lot of research in, which is, most of them were cultivated meat related, because Stanford has a very strong, like, biomedical section. And so I was primarily reaching out to professors in that area, and I was looking at their sort of research work and the papers that they've written. I'm like, okay, this is, like, somewhat related to this particular problem area. And so in the cold email to them, I'd say, like, hey, this is a potential problem area that you can work on, and I know you have expertise in XYZ. And GFI is now doing or at the time they had, like, a grant program that they're running. Like, you can apply to get funding to do research on this particular program in alternative proteins. And think we reached out to at least 20 or more professors, and I think two of them expressed interest in submitting an application for that funding.
That's a pretty decent hit rate for cold emailing professors and asking them to
Yeah.
potentially shift the focus of their research, which can be a somewhat ingrained sort of path they've already gone down on. That's a fair effort.
Yeah. Thank you.
Is there is there a lot of scope for academic research in the alternate protein space?
Absolutely. There's just so much that needs to be done. There's so many, like that solutions database is over like 50, I think,
Mm.
problems that need to be solved.
Actually, I was on that the other day, and I think there was something on the order of like, yeah, over 50, but at least like 28, 29 of them were in the sort of manufacturing process
mm,
sort of category. So I think there's quite a lot of ideas on there that engineers could jump on for final year projects or for capstone research projects if they want to work on the old protein project at their local university chapter. I think there could be some really valuable ideas on there to run with.
yeah, for sure. And even if the professor themselves doesn't necessarily feel like they have the capacity to take on that type of research, a potential route you can go down is doing like a research assistantship with them, where you're doing the research in that particular area and they just provide more of a supporting role or mentorship role, I guess.
Yeah, yeah, that's awesome. So let's chat a bit about the podcast. You've been doing this for what, about a year and a half now?
Just a little over
A
a
little
year.
over a year. And so what were you mentioned you are hoping to sort of actually start going through your list of career guide careers and chatting to people. What's been sort of the most interesting thing that you've discovered by doing that and actually chatting to the people who are sort of boots on the ground doing the work in the alternate protein space?
Um, I guess one sort of interesting takeaway for me was that there are more people working in this space than I'd ever kind of realized, and these unique roles actually do exist. Um, like I when I wrote the guide, I just kind of like, oh, this seems like a way that you can actually contribute, but I didn't know particularly of anyone who was doing that particular like role. Like I was like, well, I feel like this is something that someone is doing somewhere, but wasn't. I didn't know for sure. Um, I guess one example being like one of my guests was like a food law expert who was helping to develop or helping alternative protein companies with regulations. And like that's such a cool thing. Like I never really would have thought about that. And they just sort of made that their own career path. So I think that was things like that are really unique and kind of like stick out in my mind.
That's awesome. Have you found that people in the industry are pretty open to getting cold messages on LinkedIn or cold emails that are asking to have a chat and sort of connect?
Oh yeah. As I mentioned before, everyone's extremely open and supportive in this industry, and it's such a great to be so great to be a part of it. Um, and yeah, just very receptive, and especially the people that I'm specifically targeting for my podcast are what I like to call like the average Joes or Josephines. um, where because most podcasts they interview the sort of the top CEO and they just say everything, and everyone's sort of heard their story before, but no one really knows what it's like working sort of boots on the ground, like the average person just working in the industry, those some more smaller, lesser known roles. And so when I, at least from my perspective, when I reach out to them, like I feel like they're like, oh, like you want me to be on the podcast? You don't want the big CEO to be on there? Oh, okay, sure, that's great. Like they feel a little more special, I guess, and recognize like, oh yeah, like my efforts do matter, and they do. Like the CEO isn't the only one that's working for the company. It's a team, and everyone contributes, and everyone has a key role to play. And I want to highlight every role.
That's awesome. So let's shift to talking about your role now at New School Foods. So New School Foods is making whole cut raw salmon fillets, as I understand it, which is quite quite a peculiar thing in the alternate protein space. It's got aligned muscle fibers, connective tissues, and fats. I'll have to put a photo of it in the show notes because it looks terrific. Like it looks absolutely unreal. Um, can you perhaps explain a little bit how the actual fabrication or manufacturing process works to produce a raw looking, and I assume actually raw salmon fillet that can be cooked?
Yeah. So the product that we're making is, as you mentioned, like it's a whole muscle shaped salmon fillet, uh, in the sense that it's not just a fish stick or a crab cake or um, anything that you'd buy sort of at a grocery store. Like this is a raw, like as you said, raw, like as in ready to cook, not ready to eat product. Just to be clear, like it's not meant for sushi. We're not going sushi salmon. We're making a salmon fillet that you would bake in an oven or pan fryer, sous vide, or however you like to cook your salmon, like as like a real off of the piece of the fish, I guess. Um, and so the process that we're using is not extrusion, because extrusion will not give you the texture that you want for a salmon product, because salmon is, and fish in general really, is very unique in the sense of its nutritional profile, as well as its structure and texture. And particularly with salmon, when you think about it, there's sort of the way that it flakes, like there's sort of layers to the salmon, and that's because there's that connective tissue in between the layers, and so our product is actually able to flake like real salmon. Like those um, layers are able to come apart from one another when you push it with a fork, like real salmon does. And so that's one whole aspect of trying to get it to flake like real salmon. And then there's the more of the fibrous uh, texture to the product. And like most meat products, like steak or chicken, there's always going to be those sort of fibers that you see in the product, and that's sort of what makes it like meat. And it's really difficult to get that fiber structure with an extrusion product. And so the method that we're using is extremely unique and novel, and I'm personally not aware of any other company that's using it, and it's called directional freezing. And so that's where we freeze our product in during the processing in such a unique way, where it forms these fibers that allow us to then um, give it that fibrous structure that you'd see in a real salmon fillet.
Interesting. So I had a quick look through the patent on this because I was fascinated by how it worked. So my understanding is you basically get a really cold plate and you put a gel on it, and then you put that plate in a freezer whose ambient temperature is a bit warmer than the cold plate, but still below freezing. And then it kind of freezes outwards from that plate or upwards from that plate. That gel freezes upwards, and then you get this this structure. Is that right?
Yes. So um the the freezing front sort of moves in a sort of 1D fashion, and that sort of creates this scaffold with the fibers in it that we then use for our product.
Interesting. And so is that scaffold like the connective tissue between the flakes of salmon, or is it something else?
No, that's what creates the fibrousness of it. The connective tissue part
Right.
is something separate.
Okay. So where do the proteins come into the process then?
That's a downstream process.
Gotcha. We've sort of covered like what the differences are from extrusion, but what's sort of the main benefits and maybe some of the weaknesses of using this freezing process instead of
Mhm.
extrusion?
Yeah. So one of the main benefits um, is that it's essentially very simple. It's not very complex. Like we've done a lot of research and we have a very decent understanding of how it works, and it's very tunable and adjustable in the sense that we can use this technology not only to create scaffolds for fish, but potentially other meat products as well. Uh, and so that in itself, its flexibility and adaptability is another key benefit. The fact that it scales up really easily is a huge limitation to extruders because extruders are an enclosed vessel and they're very, very expensive. Like they have specific temperature and pressure control, and if you don't get it right, it's not great, and you have to have a whole long cooling die. Whereas directional freezing, it's you just sort of scale it up and make it as large as you need it to be, and it's currently done on a large scale for other industries. So which is why we know it's proven to work on massive scale. So that's one key thing that's already been done. Some development there. I guess more of the main short-term limitation of it is there hasn't been, aside from our company, there hasn't been much research into utilizing directional freezing specifically for developing alternative protein products. So that just needs further R&D to really get it to that next level. But that really is all I see as the main drawback for now, at least until we fully develop and understand that technology, which will just take some time, but we're getting there.
Interesting. What are some of the challenges with scaling up this type of technology? Both from like an engineer, like an R&D perspective, but also maybe just from like an engineering company sort of implementation perspective.
Like for this technology in particularly, there aren't very many challenges associated with it. I guess maybe the main ones being how to integrate it with the corresponding upstream and downstream processes are probably the main limitations in utilizing it in a way for alternative proteins. Uh, but other than that, like all the other sort of scale up challenges still apply. Just sort of trying to move things on from you're just doing currently on the bench scale versus doing it on more of an industrial scale, and just trying to figure out what parameters and what will change when like you're doing it when say 100 liters versus 1 liter. How will that influence the like fluid properties or the heat transfer?
Interesting. And so this is like a challenge just faced by the industry as a whole, really, as they're going from these
Mm-hmm.
benchtop sort of experiments to full scale factories.
Yeah, and another one being like it's easy to do things manually on the lab scale, but once you move up to larger scales, things necessarily can't be done manually anymore because it's just not feasible.
Yeah, and so this is where you need engineers to come in and sort of help with the physical automation
Exactly.
aspects and getting getting that sort of those efficiencies of
Hmm.
scale going.
Very true.
Interesting. So what's your work at New School Foods entail then?
Um, so many different things, and just being the nature of a startup work, um, I get to wear a bunch of different hats, and I absolutely love that. It's never a dull day as a result. There's always something new and challenging and exciting to work on. Um, and that just applies not just for me, but anyone working at a startup. So, but getting back to your question of what specifically I do as the process engineer, my role entails a bunch of different things. Some days I'm actually in the lab running experiments alongside the food scientists, and trying to gain a better understanding of how different changes to our process will potentially influence our scale up. And if we would change certain things, how will that adjust our some of the pieces of equipment that we're looking at, which leads to the next thing that I do is like looking into um, procuring pieces of equipment for our pilot production line, trying to build out what that process is going to look like, and really getting an understanding of like building out like a schedule of like how what things are going to be done at different parts of the day. Um, a lot of spreadsheet work doing calculations to figure out things out like that, and specking out volumes and that. Also, a lot of my work is coordinating with other consultants and contractors, so the people who are actually doing the design and like physically constructing the facility, coordinating with them to ensure that everything's going and running smoothly. Uh, Also assisting with sort of building out the budget for the facility, and sort of documentation around that. Um, yeah, and just putting out fires essentially. As things always go wrong. Things pop up. Maybe a piece of equipment breaks down that we're working on in the lab, and having to go and try to fix that. So just getting very involved in all of the everything that goes on in the in the business.
That sounds like a really broad and just really fun set of things to be able to do, and just a great sort of breadth of exposure to just how businesses run and how startups run, and then obviously specifically in the alternate protein space. It seems to me like a lot of particularly the startups, but even some of the bigger alternate protein companies probably just don't have that many engineers involved. Probably more so at an early stage, and so have you got sort of a sense of how that sort of changes the perceptions of you coming in as the engineer? Like, are you sort of expected to be able to do all these things, or is it sort of you're hired for a very like a more narrow sort of role? Because my impression of a lot of engineering, I guess, if you go into sort of like just traditional industries, you're going to be doing a relatively narrow uh, set of tasks, and like obviously this is a, a gross generalization, but it seems to me like obviously in the startup space, you're just going to have a broader range of responsibilities. But do you think that the alternate protein space is sort of broader still just because of the few engineers that are in the space, or
Um, like when I got brought on to New School Foods, I was the first engineer in the company, uh, and I sort of had to take on all of the engineering responsibilities, uh, and there are a few things that were just out of my wheelhouse. Like I just didn't have the capacity to do so. Primarily, just like constructing. like fabricating prototypes. And so we sort of put out a job description for a sort of more mechanical engineer to take on that style of work. And as I was writing the job description, I was like, hey, he'd be great for this job. My friend who helped me or did a lot of the prototyping work for the Capstone project that I did, and that we'd worked on together. And so I reached out to him and asked him what he was doing, and he's like, "Oh, I'm not much." And so I'm like, "Hey, well, you want to join this plant-based meats or plant-based fish startup?" And he's like, "Yeah, that sounds really interesting." And one thing led to another, and we hired him shortly afterwards. And so I say that to say that there is a little bit of you are expected to have some sort of areas of expertise. Like, I don't take on all of the engineering work. And so we do sort of segregate it a little bit. Because engineers really aren't jack of all trades, so to speak. And so, and for things that are still currently out of our engineering wheelhouse, we rely on other consultants to help sort of bridge the gap.
Interesting. So there's no, the threshold or the bar isn't that high, or isn't unachievably high for engineers who are entering the field. That there will be things that they can do and things that are maybe like on the edges of what they can do, and then past that it'll just be having somebody in house who can sort of draw the line of what can be done in house and what can be done, or what needs to be sort of hired for, or consultants to bring in, is sort of one of the things that can be valuable in that role, I guess.
Yeah, absolutely. And this is just based on my personal experience, but the engineering team that I worked on at Rebellious Foods, there are about 5 or 6 of us there, and all of us were graduates within, like, had graduated within the past 5 years. So we're all fairly young and relatively new engineers, I guess. And so I just only add that to say that there are roles for young engineers in this industry.
Yeah, it definitely sounds like it. What's been your experience with, like, for people who are sort of perhaps further on in their career, maybe they've got, that sort of 5 to 15 years sort of range of experience, or maybe even more. Do you have a sense of how they sort of fit in to the equation here? You've mentioned that there's plenty of opportunity for graduates to come in and be doing, working as part of teams, or very early career engineers coming on board with these startups. But yeah, where do the sort of the later career people fit in?
Later career people can fit in almost anywhere as well. One of the bigger needs, and as something I've noticed both at Rebellious and with New School Foods, is as the engineering team starts to grow, and as the company starts to grow, someone really needs to come in and take more of a leadership role or management role for just the engineering team. And so there's definitely roles like that where more experienced engineers are needed to sort of bring together a group of the sort of younger engineers and mentor and help them through their engineering development.
Interesting. That sounds like a really impactful position to come in at as well. Bring out if you can bring across some skills from an adjacent industry and just bring them to bear on this sort of nascent industry that's really just sort of bootstrapping and trying to get things from the lab to a scaled up facility. It sounds like a really fantastic opportunity, and quite a fun way to get in, I guess.
Yeah, and like a lot of people who have a lot of experience in the food industry, doesn't have to be alternative proteins. That's extremely beneficial, and that's frankly what a lot of alternative protein companies look for when they're hiring for new people, because they don't expect you to have experience in the alternative protein industry, but they would expect you to have experience in the food industry, because the alternative protein industry is in the food industry. And so that's probably where, if you have that skill set or that background, that's really what those are the types of people that we're looking for.
Interesting. Are there any other industries outside of the food industry where there's skill sets that are really valuable for alternate protein?
I would say probably pharmaceutical, mainly because a lot of at least on the cultivated meat side of things, the bioreactor design is very. There's a lot of parallels between sort of cultivated meat and pharmaceuticals. I don't want to say that they're exactly the same, but I think you can definitely leverage that if you leverage your experience in pharmaceuticals to potentially get into that industry. Another one would maybe be a bit more general processing. And so if you have any sort of manufacturing or processing, even if it's like oil and gas refining or something like that, gaining a good understanding of how production systems are set up and run, although it may not be in the food industry, that sort of fundamental understanding of physically producing a product from raw ingredients and putting them through different steps and processes and equipment to yield a final product. That sort of general mindset and experience working in doing something along those lines, I think would be beneficial.
Interesting. Yeah, the pharmaceutical one's a really interesting, kind of unexpected one for me. I hadn't really thought about just how many similarities there are there with, I guess, just the biological processes that are sort of producing something that's going to be consumed by a human at the sort of the end of the line, and then also, I guess, with the manufacturing, the scale up, quality control, and things of that nature as well. There's quite a few comparables there.
Yeah.
All right, so what are some other maybe less obvious ways that engineers can contribute to the alternate protein space?
I guess one thing I would say would be, you don't necessarily have to do engineering work to contribute. I say that mainly because I feel like a good portion of at least my role isn't necessarily engineering related at all. Mainly more so sometimes requires that engineering mindset and an approach to doing things. Even just sort of the fundamental understanding of how to do like a back of the envelope calculation and making estimates and things like that. I guess sort of I can touch upon briefly something that I did between my time at Rebellious and when I started at New School Foods, was I did a sort of part-time position for Food Solutions Action, which is a nonprofit that lobbies for alternative proteins in the US. And I did a lot of research work there, trying to sort of writing what they called policy briefs that would potentially be given to politicians to help convince them to sort of develop and invest more and promote alternative proteins. And so I did a lot of research into some of the stuff that's some of the articles and research papers that are about alternative proteins. And from there, I did some back of the envelope calculations to determine sort of what some of for example, the economic benefits would be towards developing alternative proteins, and what are some of the supply chain limitations associated with transition or what are the supply chain benefits towards transitioning from alternative protein or transitioning to alternative proteins. And having that sort of engineering background and mindset, I think helped me with that role as well. And I just like to note that most engineering graduates don't actually end up doing engineering. So don't ever feel like you're pigeonholed into that particular type of engineering just because that's what your degree is in. Like I have a degree in mechanical engineering, but yet I'm now a process engineer, which is technically more chemical engineering. And I've really learned it as I've gotten into this industry. And in some of those things, you just sort of learn as you go. And I think it's important for people to realize that if you just have this limited mindset, okay, I studied this. This is the only thing that I can do. You're sort of limiting yourself. And if you're able to sort of broaden your skill set or your areas where you think that you might contribute, I think that's also important to consider. Is not just I have this background, so I have to do um, that, but what do I really enjoy? What am I really good at? Is a better approach than what did I study? And so it's sort of trying to find those where those two come together, um, can make you realize that there's many different ways that you can contribute to the industry more than just engineering roles. In terms of maybe more business roles or um, marketing, if that's your thing.
Yeah, I think policy as well is just such a great example of
Mm-hmm.
that, especially from the perspective of trying to sort of have the most leverage with your skill set and create impact. Policy just has this opportunity to be just ridiculously far-reaching. If you can put a convincing argument forward for a policy that's based on sort of rigorous evidence and research and reasoning, then that can have just really far-reaching consequences. My impression is that there could be more engineers going into policy. I'm not sure if you've got a perspective on that based on your work, but I've probably only spoken to, I think you're maybe the second or third engineer I've talked to out of quite a few who's done any sort of policy work. It just seems like a very neglected area for engineers to move into. From what you did with that project between Rebellious and New School Foods, like were there many other people with a sort of similar technical background in that group?
No, I think I think I was the only one there. But I think maybe where policy and engineering could play a bit of a role there isn't necessarily in alternative proteins, but potentially the renewable energy sector, and maybe sort of doing more policy work and because you need someone with more of that technical background to really advocate for any sort of policy change. And so having more of that engineering understanding of how renewable energy technologies work can help with sort of the lobbying of those technologies to the government to help make more of that transition from fossil fuels to renewable energy.
Mm. Yeah, that's really interesting. Do you know of many organizations or companies that are doing that sort of work in the renewable space? People who are interested?
None come to mind right now.
I know of Clean Air Task Force. I know they do quite a lot of that
Right.
sort of work and employ quite a number of engineers as well to obviously in that exact vein that you just mentioned of really having like a deep understanding of the technology or just the physical world and how that actually like how do you actually create policies that are physically feasible and work with the technologies on hand.
Yeah, and for renewable specifically, like looking at how um, the energy grid will be impacted, and that's really where electrical engineers can really strive. I know a lot of them work jointly with governments, and because a lot of the energy sort of grids are managed either privately or in sort of conjunction with sort of the government as well, and sort of analyzing how transitioning from fossil fuels to renewable energies will affect the grid infrastructure and demand and all of that stuff, cost curves and everything. It's very complex.
I can only imagine how complex that must get, especially when we're talking about national scales as well. And then, yeah, another layer of complexity as well. If you look at areas like Europe or North America as a whole, and you start getting like multiple countries coming together, trading electricity, and how, yeah, the transition to renewables for each country individually is going to, affect the whole. Yeah, need some very talented electrical engineers in there providing their expertise.
Yeah, and renewable energy is very geographically specific too.
Yeah, for sure.
Like what works in one area won't necessarily work well in another.
Yeah, 100%. Yeah. All right. Before we sort of start wrapping up, I guess, is there anything else you wanted to mention?
Yeah, the other thing I wanted to touch on was the work that I do with ALLFED. And that's more of an engineering type role. Just so for context for listeners, ALLFED is the sort of Alliance to Feed the Earth in Disasters. It's a nonprofit organization that tries to essentially do that. Try to figure out in the event of a global catastrophe how we could reliably feed the world in that case. And so it's mainly more of a research organization with some practical side of things, but I'm currently a volunteer there, so I just spend a few hours a month doing some research work for them. And again, it's one of those things where it requires more of that. At least the particular research that I'm doing requires more of an engineering background. There are definitely non-engineering roles there, but the work that I'm doing is trying to figure out and analyze how different food systems and how different food technologies could potentially be scaled up very quickly in the event of a global catastrophe with the limited resources and supplies that would be remaining, and how we could reliably distribute and feed the world or feed the remaining population in that scenario.
Interesting. So is this tied in with some of the work, also experience you've got with alternate proteins, or is it a broader sort of mandate of, or so, I guess, what sort of food technologies have you been looking at there?
Right. It is more of a broader thing, but there is a little bit of overlap. So, for example, there's a company called Air Protein, and their claim or tagline is like they make protein from air. It's they really what they really do is they make protein from the ingredients that comprise of air, um, and they utilize this bacteria. It's like a hydrinotroph, I believe, that sort of uses the inputs that are in air, so just oxygen and hydrogen, and then that's pretty much it, and converts it into protein essentially. And that has implications. It was initially sort of developed for NASA, for sort of space exploration programs. But there's also the potential, like, well, why can't we use it now to feed people? Because is in theory very very efficient use of resources. It's something that needs to be scaled, and so that is something, because the inputs are so widely available. Like that's definitely something we'd want to rely on in the event of a global catastrophe, because air is everywhere.
Yeah, that's really interesting. And Can you maybe speak a little bit about ALLFED's volunteering program and how you got involved with that?
Yeah. So I believe they sort of accept volunteers on a ongoing basis, and I just sort of reached out to them saying I found the work that they were doing really admirable and really interesting, and I wanted to frankly just learn more about it. And so I sort of signed up to be a volunteer. I can't remember if there was a form or something. If I can find the link, I'll send it to you to put in the show notes.
We'll put something in the show notes for sure.
Yeah. Okay. Yeah. And yeah, they go back to me and they'll sort of match you with a supervisor, and you'll work with them to work on a project that suits your background, your interests, and your how much you're able to commit to it. So yeah, definitely would recommend if it's something you want to get more involved with. It's extremely flexible, which is great. Like if you only want to contribute a few hours a week, that's fine. And if you only want to do it for a short period, that's fine as well.
Yeah, for sure. It sounds like a fantastic opportunity both for people in their career and also for university students if they want to, yeah, I guess
Yeah,
build out their
absolutely.
resume a little bit and add some side projects to it.
For sure. And gets you a little bit involved in food processing and the food industry if you do want to learn more about that.
Awesome.
Yeah.
What top 3 resources would you have for early career or university engineers if they're interested in getting into the alternate protein space?
Hmm. Uh, I would definitely recommend just essentially all of GFI's website. Frankly,
What's the best
they
starting point for them? What's the jumping off point?
uh, probably like the science section. I know I say science, but they call it more like science and engineering. It's kind of lumped together under like the science um, side of things. Um, I think they do have a few resources specifically for engineers. Like this might have just been like a list of career jobs or something like that. But yeah, gaining a good understanding of the different technologies. Even just reading, I think a good starting point would be reading the state of the industry reports that they produce every year, and that would enable you to read more about the cultivated meat, plant-based meat, and fermentation derived meat. Um, those are good ways to, especially if you know nothing about any of those. I think that's probably where I direct anyone as a starting point. Uh, Another resource I'd recommend again isn't like engineering and alternative proteins is extremely niche. So this one again isn't specifically for just engineers, but is a really valuable resource for at least people who want to get a career in the alternative protein space. There's an organization that recently started up last year called Talist. It's a sort of recruiting agency, and they have a job board for all of the jobs available in the alternative protein industry. And it's probably one of the most extensive job boards that I have come across for the alternative protein. So I should look up it now, actually, if there's because I know there's a filter on it, and I don't know if there's a filter specifically for engineering roles. Oh, yes, there is. There is. So you could just do the engineering filter for it and see how many roles are there. Okay, there's already quite a few just looking at it now.
Awesome.
Yeah, so definitely would check that one out. Um, but also check out the other roles. As I mentioned, don't feel you have to be limited to just the engineering roles.
Terrific.
Uh, yeah, and then third resource. Um, Shameless plug, I guess. My career guide.
If you didn't plug it, I was going to plug it. That in
Yeah,
your podcast.
yeah.
Awesome. All right. So, second last question. What do you wish you had invented and why?
Yeah. So I knew you were going to ask this question, and I spent a lot of time thinking about it. And what I sort of came up with was an invention that I think is really quite impactful, but no one really fully appreciates the impact that might have had, or at least definitely something we take for granted now, is the canning process, and making sort of canned goods. I think it really enabled us to preserve food, which was something that was extremely difficult to do, back when it was invented in the 17 or 1800s or whatever. And so that really enabled us to get through harsh winters, and so we could store food, and use it later on. And I think that definitely would help with population growth and economic growth and everything. So I think that'd be really something kind of cool to invent. And I guess if you're looking for something more physical, I'd say I wish I had invented the can opener, because it wasn't invented until like at least 30 years after the can was invented. So inventing that earlier would have been a great impact there. We saved so many people for 30 years trying to open out cans without a can opener.
There's a lot of people with wrist issues.
Yeah. Yeah, it was just primarily, I think, the canned foods were used for in the military, and people would just use their bayonets to try and open up the can.
That's brutal. I mean, there's something beautifully poetic about you having that as the thing you wish you had invented. Both the can opener and the canned foods, especially like in the context of alternate proteins, there is that sort of frontier feel where it's like, oh, if this goes really well, there could be some really far-reaching consequences to the human race as a whole, and let alone mentioning animal suffering and sort of farm animal welfare. It is a massive opportunity for innovation and for expansion of sort of our conception of the food system.
Absolutely. And that's one of the things that I really enjoy the most about the alternative protein sector is I don't really feel like I'm working on just one cause area. Like I don't feel like I'm just helping animals, because I'm also helping animals. I'm helping the environment. I'm helping sort of human health. I'm helping reduce the risks of zoonotic diseases. And so that's really kind of what motivates me and excites me about this work too.
Yeah, that's amazing. All right, well, before we finish up, where can people find you online? Where can they find we'll obviously have links to your podcast and your careers guide in the show notes, but where's the best place for people to reach out to you if they want to get in touch?
Yeah, they can reach out to me via LinkedIn or via email. I'm always happy to reply to emails. It's jeffraybehr@gmail.com. Very simple. You can put that in the show notes as well. Same with my LinkedIn profile.
Terrific. Well, Jeffray, thank you very much for joining me on this podcast today. This has been a fantastic chat, and I've enjoyed it thoroughly.
Yeah, same here. And I really appreciate you inviting me onto your show. And I really wish you all the best with this podcast.
I hope you enjoyed that conversation with Jeffray. For detailed show notes and valuable resources related to this episode, please visit engineeredfoриmpact.show/Jeffray. That's JEFFRAY. You can support Engineered for Impact by leaving us a review on your preferred podcasting platform, dropping us a comment on the YouTube video for this episode, or heading to engineeredforimpact.show and leaving us anonymous feedback. You can also support the show financially. Engineered for Impact is brought to you by our foundation, High Impact Engineers, organized in the USA. To donate, head to engineeredforimpact.show. Thanks for listening, and happy problem solving.